Bismillahirrahmanirrahim. Now, second lecture will start. Hello, gentlemen. Hurry up, please. Everybody should join now, so I could start lecture in time. You are taking too much time, and you must have already done that. Hurry up, please. Everybody, call everybody to join. Let us start. So we were discussing this static regain method principle, and then we discussed again how to do calculation from that duct flow chart, duct design chart given in your textbook, and that was volume flow rate versus delta P per unit length, and diameter and velocity. The diameters were calculated based on velocity method and equal friction method. Static regain method was discussed from this. Let me admit, everybody, they are late, and late. Now, let us talk about, in this lecture, performance of duct system. What is duct? Once you have designed duct system, as shown in the above layout, now we must discuss performance of the duct system. Duct system is designed by engineer like you with the help of scientific calculations, but it is installed by illiterate workers. It depends on technical skill of the workers and honesty of the workers and technical honesty of the contractor, how they are dedicated to accurately maintain the duct sizes. So if there is some manufacturing defect, fabrication defect, then the system will not work as designed by an engineer. So for that, we discuss performance of the duct system. Performance of duct system means is the flow rate in a particular section of the duct is same as was designed by the engineer. Now, installation, what is the ground reality? So we have to compare ground reality with the design one, which is theoretical. So theoretical design is ideal thing, and installed is a real thing. So real flow rate is measured, and real friction and velocities are measured in each and every section and outlets of the duct system, AC duct system, and compared with the calculated one by the designer, like you. Now, for that, we have to discuss this diagram, which is shown in my notes also, and it was discussed earlier in previous lecture. Let us discuss only one part of that performance curve. This is system design. This system performance. On y-axis is delta P total pressure drop. Total pressure drop means static pressure drop plus dynamic pressure drop, rho v square by 2. Static pressure drop is measured by the pressure gauge at one point and at the other, and difference calculated. And total pressure drop is measured by the velocity at one point and the other, and calculated formula rho v square by 2. Now, velocity can also be calculated from formula volume flow rate is equal to area into velocity. So once you know cross-sectional area of the duct, you can calculate velocity. Velocity is equal to volume flow rate divided by cross-sectional area of the duct. So once you know velocity, flow rate, volume flow rate, this is Q, meter cube per second, and this is delta PT. Actual volume flow rate is calculated by velocity, measuring velocity with the help of an instrument called pedometer. So with the help of FreeTalk, you might have learned fluid mechanics, you might have learned in the thermodynamics one, but how pitot tube works. Now, having the knowledge of using these instruments after installation, a separate engineer informed our engineer called commissioning engineer. They measure each and every thing, each and every place these flow rates. So once you know this flow rate versus total pressure drop, you can draw this curve. This is hyperbola, curve A. This is designed by the engineer before installation, before the project is commissioned. Now, this is curve B and C may be actual. Actual may be higher, this curve actual may be lower than this. So you can see at one flow rate, say here, delta P design was this much. Actual can be this one, actual can be lower than this, higher or lower. So this is how we draw system curve. System curve is duct performance curve. So after duct performance, we must put on this fan performance curve. So fan performance curve is done by the manufacturer. And in manufacturer's catalog, you can find curves like this. This blue curve. This blue curve, this is manufacturer's catalog. This is called fan performance curve. In fan also manufacturer for one RPM, for the same fan, 1 RPM omega 1, another RPM omega 2. In SI system, we talk about RPS, rounds per second. So 1 RPS and another RPS, omega 1 and omega 2 curves are different. This is one curve at high speed, omega 1, a lower speed, omega 2. This is the curve. So this has been overlapped on this diagram, which was fan duct system performance curve. So if you select this RPM, you can see that performance of the fan will match the system over here. Point 1 is the matching point of the system. Duct system and fan performance curve meet here. So that means that omega 1, Q1 will be the flow rate and delta P total will be this much, delta P T1. Now we reduce the fan velocity, omega 2. So omega 2 is than omega 1, then it will meet the duct performance curve at point 2, and at this point, at low speed, fan will give this much flow rate, Q2, and its delta PT will be delta PT2, and this knowledge is required in order to set the balance point between the system and between the fan and actual ground reality conditions, because sometimes cooling load may be less than maximum design. So in Q1 was the maximum flow rate required for high cooling. Q2 is the lower flow rate required for low cooling. So cooling, depending on weather and date and time, so we may cooling requirement may be less. So we may reduce the fan speed to meet this requirement at Q2.2. So this is how we use these performance curves. So we have already discussed fan laws. We have already discussed performance of the curves system. So you can learn again, revise again this theory. So let us read fan laws again and system performance curve again. So it has been done already. System needs balancing. System needs balancing. Balancing means check on the ground what is the actual flow rate, what is the actual velocity, what is the actual static pressure at a particular point in the duct system. So now we were discussing performance of the duct system. For duct system with air in turbulent flow, the total pressure loss delta PT is proportional to square of the flow rate. That is, delta PT is directly proportional to Q square, where Q is the volume flow rate. Of total pressure drop, delta PT is equal to a constant C multiplied by Q square, when C is the resistance offered by the duct system. Now, Once the duct system is designed and installed, the value of C is supposed to remain constant. However, if the air filters installed in the duct become, during the passage of time, air filters are always there. So filters installed in the duct become dirty, and or in other case, damper position is altered. Some operator may have changed damper position by mistake or just by requirement. Then the value of C will change. Thus, variation of total pressure drop with airflow rate is parabolic in the nature as shown in that figure which I've shown you. In this figure, the curve A refers to the performance of the duct at design conditions, while the B curve refers to the performance under the conditions of a dirty filter and or higher damper closure, and curve C refers to the performance when damper is opened more. So this was the curve which I have shown you, curve A, B, and C. You can see it again. So in this case, for duct characteristic constant resistance, one can write delta PT upon 1 divided by delta P upon 2, delta P2 is equal to Q1 square by Q2 square, because delta P is proportional to Q square. Now, thus, knowing the total pressure drop and airflow rate at design conditions of one can obtain the total pressure drop at an off design condition 2, and using the above equation. Now, system balancing we will discuss. System balancing is a very, very technical job and very expensive job. There are specialized contractors of air conditioning consultants who perform this job, and it is not free, it is very expensive. They need purchase of expensive equipment, they need training of expensive engineer who is paid higher salary and who needs special training, and every training needs money, every instrument needs money, every engineer has to be paid. So this job is very expensive, but obligatory, compulsory by law in all municipalities of the advanced countries, and it is compulsory by state law in USA, by the federal law, and by professional bodies laws like ASHRAE, like SIPSE, and all that. So they make sure. ASHRAE has made regulation that consultant who is designing the HVAC system is responsible for accurate commissioning of the system also, because on the commission of the system depends performance of the system, how it will perform. And since HVAC does not run free, it must consume energy, and you know HVAC and lighting takes more than 70% of the world total production of the energy. So it is a serious business, and you have to adjust it, balance it, so to run optimally, to economize, to save money in terms of energy consumption. So that is why in large buildings, after the air handling unit is installed, it has to be balanced for satisfactory performance. System balancing requires as first step measurement of the actual airflow rate at all supply air outlets and the return air inlets. Then the dampers are adjusted so that actual measured flow rates correspond to the specified flow rate, that is design flow rate. System balancing may also require adjusting the fan speed to get required temperature drops across the cooling and heating coils and required airflow rates in the condition zone. Balancing a large air conditioning system can be a very expensive and time-consuming method and may require very accurate instruments for measuring airflow rates and temperature. However, system balancing is always recommended to get the full benefit from the total cost incurred on air conditioning design. Total cost is the sum of initial cost, purchase of the equipment, installation of the equipment, cost of the building, and running cost. Running cost is the consumables and utilities, that is gas, electricity, and water. So large air conditioning systems require optimization of the duct system, duct design, so as to minimize the total cost, which includes initial cost of the system and lifetime operating cost. At present, very sophisticated commercial computer software are available for optimizing the duct design. When you will join a career firm, a contractor firm or consulting firm in Pakistan or in a foreign country, they might be running some commercial software. They are very expensive usually, and you must pay first attention to that software to be able to run that software. For large commercial buildings, manually it is a very tedious job. In the field, you don't have enough time to consume in reading the books and calculating. You must use effective tools like commercial software to do your job in seconds. So one such method is called T method. The reader should refer to advanced textbooks or ASHRAE handbook for detail on duct optimization method. Duct optimization method is a very advanced technique, and you need MSc and PhD degrees to perform this job. Now, fans. The fan is an essential and one of the most important components of the almost all air conditioning system. Thus, a basic understanding of the fan performance characteristic is essential. Thus, a basic understanding of the fan performance characteristics is essential in design of air conditioning system. The centrifugal fan is the most commonly used in air conditioning systems as it can efficiently move large quantities of air over a large range of the pressures. So, thus, operating principle of a centrifugal fan is similar to that of a centrifugal compressor. The centrifugal fan with forward curved blades is widely used in low pressure air conditioning systems. The more efficient backward curve and airfoil types fans are used in large capacity high pressure systems. So here is mentioned different types of fan blades. Centrifugal fan may have forward curve, they may have straight radial blades, they may have backward curve, they may have airfoil. So four types. Centrifugal, that is radial fan, radial blades, forward curve blades, backward curve blades, and airfoil type. Airfoil means they are designed just like air wings are designed. Aircraft wings are designed. So knowledge of aerodynamics and compressible fluid flow is required. If you can design aircraft wings and aircraft body, you can design airfoil type fan blades also. Now, fan laws are required in order to simulate the performance of one fan against another, or one fan at one speed against another speed. Now, the fan laws are a group of relations that are used to predict the effect of change of operating parameters of the fan on its performance. The fan laws are valid for fans which are geometrically and dynamically similar. If you have centrifugal fan with forward curve, you can compare performance of other fans of similar fans with different capacity and show how it will perform when it is purchased and installed on your system of ducts. Now, the fan laws have great practical use as it is not economically feasible to test fans of all sizes under all possible conditions. Manufacturer will give you 2-3 sizes, 2-3 performance curves, and the rest you have to do by your calculations which fan suits you, suits your system. Else you do not have time to perform research at the building where you are required to balance the configuration of the fan and duct system. Now, the important operating parameters of fan fixed diameters are, when diameter is fixed, same size fans, so density, number one, density of the air is a parameter, important parameter. It depends on temperature and pressure of the system, duct system. Other is operating speed, RPS. This is important, how fan is supplied, the manufacturer is supplied with how much speeds are adjustable. There are adjustable pulley drives, pulley and belt drives, which can be adjusted on the side to run the fan at your required speeds. So size of the fan is important. What is the diameter of the blade? What is the diameter? What is the capacity of the fan? How much flow rate it can give at a particular pressure? So this is called size of the fan. Now here the fan laws related to the density of the air and rotating speed of the fan are considered. The effect of the size of the fan is important at the time of designing the fan. For a given air conditioning system with fixed dimensions, fittings, etc., it can easily be shown. So once you have purchased the fan of a particular size, now you have to match with this formula. Q is directly proportional to omega. If you want to increase volume flow rate in your air conditioned space, then you must increase the RPM by adjusting the adjustable pulleys. And static pressure, if you want to reduce the flow rate, then you have to reduce the speed also. Now, static pressure rise, delta PS of the fan, it is proportional to rho V square by 2. What velocity has been designed your duct work, that is V. So density, you know, depending on the temperature of the supply. So rho V square by 2 will tell you what is the delta P is proportional to rho V square by 2. So if delta PS is very high, you have to reduce the velocity by changing the duct size or by taking other measures. So reducing the RPM of the fan. Now fan power input formula is, it is proportional to pressure drop, it is directly proportional to volume flow rate. It is directly proportional to delta PS. Volume flow rate multiplied by delta PS, this is the power required to run the fan to provide this by delta PS. Delta PS is required to run your duct system. So plus rho V square by 2. At the discharge of the fan, there is a dynamic head also. That is the velocity. Velocity has a kinetic energy, and that is equal to rho V square by 2 multiplied by volume flow rate. This is kinetic energy taken by the flow rate required. So total power required by the fan is equal to total power required to create static pressure delta PS and flow rate Q dot, and to create this velocity multiplied by this flow rate. Now, from the expression, from the above expression of the fan power input, it can be seen that first term on the left, on the right hand side, for the power input, this one first term, it is required for increasing the static pressure of the air, and second term on the right hand side, this much I have already told you, and this is for power. This is the power required to impart the kinetic energy to the air and to provide necessary velocity to run the duct system. Using above relation, the following fan laws can be obtained. Law number 1, 2, and 3. There are 3 laws. Volume flow is proportional to omega, that is RPS, and delta P is proportional to omega square, and power is proportional to omega cube. This I discussed yesterday in my notes also. This is written in very compact form. This is more beautifully typewritten. That was handwritten. Now, second law is air flow rate remains constant and the density varies. Now, if Q is constant, if Q is equal to constant. Here, if density is constant, law 1 will apply. If volume flow rate is constant, then law 2 will apply. Delta PS will be proportional to density, that is temperature. And power will be proportional to density, that is temperature. Now, third law is applied when delta PS remains constant, static pressure remains constant, then density is variable. In this case, we will apply third law. Third law of fan says that volume flow rate of the fan will be inversely proportional to the square root of density. And omega will be any rotating speed in rounds per second will be proportional to also reciprocal of under root P, under root rho density. Power will be also proportional to reciprocal of under root rho. So this is how we apply fan laws to run and balance and adjust the fan and duct system, and in a one compact form it is shown in this diagram. This diagram is handwritten also by me in my previous slide which I have shown you, and I will give you a copy of all this reference material. Now, pressure loss. This figure, so interaction between fan and duct, I've already discussed. So I've already discussed, and I think here I should stop my lecture, and lecture is over. So please wait. My homework, assignment, reference material, I'll send you by email. I've already sent you homework about cooling load calculation, and submission deadline is perhaps 8th of June. So please do all homework assignments. Students who are not who homework assignment, they will lose marks, they will not get marks, because in this ODL system, university UET has already decided the rules and weightage of homework assignment and quizzes and written test, everything. So this, you can take it as a written test, you can take it homework, assignment, quizzes. This all carries 70% mark. Whatever we are delivering you, it carries 70% weightage. 30% will be based on Viva. Viva will be taken just like final year project. Viva in groups or individually, you will come on video and you will answer to the questions of the teacher instantly, and he will assign you time in seconds, and you have to answer in seconds, verbal questions, and teacher will evaluate you. That will carry 30% marks. Okay, wish you good luck. Let us end the lecture.